Hello everyone. DSCI's National COE for Cybersecurity Technology Development here comes up with another webinar on levels of digital industry. I would like to introduce our guest speaker, Mr. Sudarshan, who is from ABB Corporate Technology Center. Over to you, Sudarshan.
Thanks, Srishti. Thanks, DSCA and NCOE for hosting this seminar. Good morning, everyone, and namaste. Welcome to this talk, and thanks for taking your time to join for this seminar or the webinar, as the current terminology goes. So today, the idea is next an hour 10 minutes, we'll look at the digital industry that we are hearing so much. What are those levers? We have a lot of thinking and expectations of, oh, this is what might be contributing to the digital industry from what we see and what we hear. Many times what we need to understand is why certain levers are becoming critical, and what is the root cause or the fundamental reason for this change that is happening. So what we plan to do is in this talk cover what are the things that are the paradigm shift which are actually happening, because of which the digital industry revolution looks visible, and we are going to get better out of it. So that is what we'll try to cover. Before we go into the details, like Srishti introduced, I'm currently working with ABB. Many of you might be aware of it, some of you may not be. It's a global company handling industrial automation, electrification, supporting infrastructure utilities and all. And I am with their R&D team and working on several aspects, including engineering, cyber physical systems, security, analytics, and so on. And while I do all that, let me confirm few things before I start off. The first thing is most of the material in this content are available if you do the due diligence. There is nothing secretive or purely proprietary per se. So the documents and materials are available in public. Okay. So to the extent possible, for anyone interested, I have provided the references and the sources so that you can actually go forward and go ahead if you are interested or want to do a little bit more deep dive in any specific topic or technology or any example that is cited here. And of course, while the content may be not known, the comments, opinions, they are all from my understanding and my experience. So it does not represent either the DSCI or the National Center of Excellence or ABB for that matter. So these are all purely personal, and it's a subjective understanding by myself over a period. Of course, I have learned a lot from my colleagues, my friends, and network all around. That has helped me. However, what I'm going to specific, only I have to own it, nobody else. So the responsibility lies squarely on me on the comments and opinions. Okay. So with that disclaimer in place, I will go ahead with the outline of the presentation. And if you really look at it, I'll spend quite a bit of the time in this presentation on the shifting paradigm, because that is where there is a good chance we may miss out on why certain things are happening, or the surprises that are coming up and why are they happening. If you understand the paradigm shift that are happening, for example, if you consider COVID, we are talking of a new normal. So what is the new normal? Can we foresee it by understanding the paradigm shifts that are happening across the globe, across the industry, across technology? So that is what I'll spend quite a bit of time in this talk. And then subsequently we'll look at what it means to say think global but act local. And then we'll look at what a digital industry is. And then of course the levers, and then some concluding remarks and interaction. We'll leave about 15-20 minutes for potential two-way communication towards the end of the presentation. That is how it has been scheduled and planned. So now I will change into the shifting gears, getting into the shifting paradigms that are resulting in the digital revolution. So industry digital, let's say, just one segment of the digital revolution that is happening right now. So these paradigms, there are many, but I have singled out some 7 of them. Typically, people say top 3 are the easy to remember and good to know. And but I thought better to put about 7, so that depending on the domain that you are coming from, because I do know that the audience is a mix of general interest public, and we have students, we have faculty, we have industrialists, and then we also have few people working for the government and so on. So since the audience is mixed, I have provided some 7 paradigms, and then maybe you can pick up the top 3 or top 4 that will affect you as an individual or as an organization. But these 7 will pretty much cover the gamut of shifting paradigms that are happening right across. So I will talk a little bit about what do you mean by the traditional experimental to where we are moving forward, which is totally interdisciplinary. And then we look at what does a digital transformation result in? How does it matter? And then we'll look at what is traceability, which is becoming very critical now that it is much more easier to explain, given that we have COVID-19, Arogya Setu, the contact tracing. So how is it extended in this paradigm shift of digital industry? So the traceability is going to be a key aspect, and probably that is one aspect that will uh, require everything else to fall in place. And then the availability and access to the information ubiquitously, because information is available ubiquitously, we can go one level up the hierarchy to look at the knowledge part. So far, world has been talking about data management and information and things like that. But I think knowledge management was only a dream. Now that is becoming reality. So which will ultimately result in being able to provide voice input. That is what we are looking at. Then
Sorry
the
to
other one,
interrupt, Sudarshan. Sudarshan,
yes.
can you please speak a little louder? People are unable to hear you.
Okay. So
Would
thanks
it
for
be
the
great?
feedback, Srishti. Is it better? Now I'm just trying to speak a little louder and closer to the
Yeah,
mic.
it's better.
Uh, okay, so thanks. So maybe now I'll just walk through the paradigms quickly. One side, we are going from traditional discipline-based approach to interdisciplinary approach, and then we are going all the way from digitization to digital transformation, and then traceability is becoming a very key aspect of everything that we use in life and access in our life, and data becoming ubiquitous, enabling knowledge management. And then given that we have to now work in virtual environment, which has been accelerated due to COVID-19, we are looking at interaction in an immersive experience. So we would still like to kind of get together. We would like to hang out together, albeit in a virtual way, because the travel is going to be more difficult and restrictive. And then how do we still get on with get together and being close when social distancing is the norm? So immersive experience is something that is going to uh, already it is in place, but it is going to take a big leap in terms of how much it will become pervasive all over the world and each and every thing that we interact today. And then the last part, which is related to business or finance, end of the day, money matters. So the way people are moving from Capex to Opex. So those are the things we'll touch upon today. So we'll start with the first one. Probably one of the most important one or critical one. Uh, what you are seeing right now on the screen, as I say, it is visible to about 90% of the audience. So I'm just waiting a little bit so that they can see it on the screen. So what is happening is, what you see looks like kind of a cantilever bridge or jumping board on a swimming pool type. But essentially, this one is a bridge that is being built in Netherlands, Amsterdam. Uh, so what you are seeing is a bridge being constructed by a robot. Um, so essentially, this is a 3D printing that is happening, which is very, very interesting because nobody would have imagined. that a bridge can be constructed using 3D printer. We are all hearing 3D printing as one of the game changers in terms of technology, but what it has done is, in this case, it is not just the 3D printer, but extending it and expanding it and thinking out of the box by combining lots and lots of disciplines. The civil engineers who will actually design the bridge, and the mechanical engineers, because it's a steel bridge, so they have to come with the material properties and the mechanical related aspects of that. And then there is the robots involved, and then these robots are have to handle this industrial grade uh, steel printing, which means they need special tool that are required, and the design itself requires a non-traditional software. And in the end, it's a combination of IT, multimedia, graphics, then even the people working. This is a new experience, when some 3D printing of a steel bridge happens. How do you protect the construction workers? What kind of hot air or fumes can come? So there is also this environmental things and protecting the employees from the hazardous things that can be happening when the noise is coming or the fumes are happening, or during welding the sparks are coming through and so on. So if you actually visit the web page, you will realize that there are more than 8 different companies from different expertise coming together to make this a reality. This would give a hint that we are no more talking about discipline-based or experimental approach. Uh, Way early in the human evolution, everything was experimental. People tried with many things, whatever worked, people started copying and went one stage at a time. Then we started developing some scientific base for it, and we created discipline. Then we said somebody doing electronics engineering, somebody doing pharmaceutical, somebody doing civil engineering, and so on. So the discipline-based approach was like focus on one topic and go deep dive into it. That is not going to solve problems of this nature. I think we have done enough there. Today the world is about being interdisciplinary. We have to think out of the box, collaborate with everybody, and result in something that is unique and different. That is the way the technology is progressing. That is what will enable the digital industry. Suddenly, think about in this one case, this 3D bridge. The steel, for example, comes from, for example, Arthur Mitchell, who is a metals industry person company. And if you look at the robots, they come from ABB, who provide industrial robots. And if you're looking at how the drawings are all handled, Autodesk is supporting, and the company itself is of course MX3D and so on. So there are a bunch of people who are coming in. It requires a lot of computing, it requires design expertise, it requires the visualization, which is now graphics, multimedia, and those kind of communication related skills. So it's a combination of multiple disciplines and multiple domains. So where we are going, the first paradigm shift that is enabling digital industries being interdisciplinary. So that is the first and foremost, which means we should stop thinking about silos or being an expert, but we should know each and everything around each other. Like the popular saying, you should be a master of few things, but jack of all. That is what is required going forward. So this is the first paradigm shift that to keep in mind, and this is applicable to everyone, even the students or faculty. They cannot think anymore like I'm working in the particular area. My topic of research is this or development is this. We have to still keep eyes and ears open for 360 degrees all around across all disciplines. And then the next one is the digital transformation itself that we are talking about. So as you see, the leftmost side um, is all about the old traditional way we manage the data. They were all stored in a physical format, maybe in the form of a file or a book or a paper or a note or picture that is framed and so on. So they were all physical. So they had their own benefits and limitations. The benefit was, since it was physically stored, anybody else cannot have access. So if you want to maintain confidentiality or secrecy, that is pretty easy and straightforward, because you have something, you keep it in a cabinet and lock it, and it is all safe, and nobody else will have access. So what you needed was basically a physical control, access control, and then anything that needs to be moved out, the person who is owning it has to take action, whether to make a photocopy of it and or like a redrawing of the picture and so on. So that is what was the old way physical things happened, and we have come out of that for quite some time. It's more than a decade that we are completely into what we call digitization, where the physical data gets transformed into some kind of an electronic data, which means we are getting into digitization, so to say. That means whatever is available in the physical form is now available in a logical form. It could be an electronic storage, or it could be a disk, or it could be even a random access memory uh, that is available on the fly. So there are various ways this can be stored. It could be a magnetic tape for that matter, or a CD, DVD, and so on. So the digitization enabled us, few things. First of all, since they are stored on a computing system or an electronic storage, which can be connected or accessed logically, which means there is no more physical access required. Wherever you are in the world, if there is a connectivity possible, we can logically look at it and have a look at where it is stored and all. The more second important aspect that came with that is because it is a logical or a digital copy of the uh, document or the artifact, we are looking at ability to copy and distribute without making any physical copy. So the ability to share was the biggest benefit of this digitalization. But the ability to share comes with its own access related issues because someone unintended also can get access to that. So those are security and safety related aspects. Definitely they are being addressed by the industry, and it is one of the key ingredients. The NCOE, which is hosting this webinar, itself is a center of excellence, addressing cyber security. And DSA itself is a data security council of India. So that is an aspect being addressed independently. But the logical storage suddenly makes the constraints of physical access to be able to do any data everywhere by anyone. That is what the digitization did. But the digitization itself enabled the access in a logical manner. But in the end, how do we make use of this access? Because there are some benefits, some additional levers that we got due to digitization. What did you do with that? So then came the digital transformation that we are, we cannot say today any industry or any organization is fully digitally transformed. It is a process that is ongoing, but many of them are on the journey. They have embarked on it, and there is a strategic requirement. Most organizations today do have something called a digital strategy, and they have probably a CDO, Chief Digital Officer, driving this digital transformation. So what does that it actually mean? So that means many things. Uh, uh, at the top, first of all, the entire data is on cloud. So the data access is one of the easiest. So it is on cloud, anybody can access, and there is no issue in terms of size. It is elastic. Unlike a traditional digitized logical storage that I was showing before, here there is no limited. It can be stretched. We can store as much as we want, and the data can grow. The capacity is elastic in nature. And then the next important aspect is not only that it is available on cloud, the connectivity is in a meshed manner. Means it is not a star like a Wi-Fi and point to multi-point and all. It is multiple connectivity with a lot of redundancies. That means anybody and everybody can access through multiple routes. Like we do right today at home. What happens? You have a Wi-Fi available for this webinar to attend. If there is an issue, we immediately switch out to a hotspot, and then otherwise we have a dongle. So we have multiple ways to have it. So it's a meshed network. The connectivity is not one way or single route. There are multiple ways by which the data can be accessed. Not only they can be accessed in a multiple way, the air gap or wired or wireless is no more an issue. It can be connected in a wired way, wireless way, using satellite or anything you name it. It is possible. So we are talking about a huge connectivity even without wire being there. And then these are now powered 24/7. That means the access is uh, every time, anytime, without any failure. The 24/7 access of the data with multiple access routes is what digital transformation enables. So that is from the availability and accessibility point of view. And once we have that, it results in the next very important aspect, which means Now I have all the data available to me, and it can be accessed across anywhere and everywhere, which means immediately it is possible to contextualize what we are looking at. So it is no more, data in isolation or, data in, uh, so silos. The data can be connected and it can be contextualized. So suddenly we are talking about something like artificial intelligence and so on, because now contextualization is something that humans are good at. Now we are able to do it in computing infrastructure, which means we are bringing intelligence of certain degree to this computing element. So we are looking at a contextualization, and the moment something is contextualized, it is possible to deep dive. Oftentimes we do hear that uh, the devil is in the detail. So these kind of things, the exception cases and the outliers, typically going by the average, we always find outliers become the new element. But with this digital transformation, with contextualization, it is possible to do deep dive. So that means there are no outliers; they are already accounted for, and there is a special thing action that could be enabled for those outliers. And not only that, you can deep dive and contextualize. We can have a look live on a dashboard, which means we can visually look at what is happening, and real time it is possible to monitor, manage. And the fact that we can just monitor the real time and also the contextual data available, plus all the past data that is available on the cloud, uh, put together, it enables analytics of a different type. Today we are talking about from simple prediction, which was even possible with a statistical model by typical interpolation, extrapolation, regression, and so on. But today we are talking about analytics that are not just predictive, but they can be prescriptive. In fact, analytics gives you the recommended solution and the pros and cons of each and every solution. Of course, these are enabled by deep learning and other technologies that are in place. But the analytics is the one which allows us to look, peep through the future as well as make use of the previous learnings and past data. So those are the things, that is what the digital transformation enables. So we get all the data and information on virtual storage, and once it is available 24 by 7, and then we are able to contextualize, deep dive, do all the kind of analytics that are possible. So having done the analytics, why do we do all that? In the end, if you look at on the rightmost thing, simply monetization. Because whatever we do, the monetization, though I have shown the symbols of rupee, dollar, and euros, and so on, whatever is the value, I will actually call it, the value generation. So we are adding value to it. For example, if you take Bhutan, we are talking about the happiness index, how happy people are with all these things. By being able to know things upfront, are we becoming happier? Then it's a positive impact. If it is not happening, then you may want to decide what kind of analytics to be presented, and so the right thing, the positive effect, so that people remain happier. So this is basically the value part, though I call it monetize, because typically we go by the balance sheet and the numbers. So from that perspective, I put it as monetize. But the reality is we are looking at what is the value that can be added. It does add value because I can predict future. For example, I can reduce the unplanned downtime in an industry. I can reduce my waiting time for catching a vehicle, be it a cab, be it a flight, and travel time to the airport, and so on. So all those things are possible with this kind of digital transformation. So this enables a new way of working. Basically, you get to know everything that you need, and you are made contextual and knowledgeable. It is not that I'm not, it is no more informed. It is actually you are becoming knowledgeable. That is the difference. When you are digital, probably at best you can get informed, but in a digital transformation having happened, we are looking at not just informed, but we are also becoming knowledgeable. So that is what is the key takeaway, and that is a shifting paradigm. So So now we talk about something a little bit different, which is about traceability. So when we look at traceability as such, What are we talking about? Long back, there was people used to do trading. Trading has been there ever since human beings are there. We are, exchanging goods, the barter system, and so on. So what used to happen? People used to go to market. You just buy what is available, and then the seller can be anybody, buyer can be anybody. So the negotiation of the terms and conditions are subjective. Maybe same item can be sold depending on the capability of the buyer or the incapability of the seller. It can be at a much higher price, or it could be at a lower price on condition that can be favorable or biased to one of the person, not good terms and conditions or fair terms and conditions. These are possible. That is how life used to be. People used to go to market, will just to go buy what is available. By they just look at the functionality, they depending on how convincing the seller is or how knowledgeable the buyer is, we take it. That is how life used to be. Then came the next stage where people said, oh no, everything should have some kind of a brand or a regulation to say that if somebody says it is clean, what does that mean? When we say clean, does it mean, purity to some level, or bacteria contamination cannot be more than some percentage? So those regulations and brand, some are coming through regulation because they are mandated by standards bodies, governments, and so on. Whereas some are created by the company to say that I am unique. I guarantee, for example, uh, uh, the most popular example could be the coffee. Everyone used to have coffee, but it is very subjective. But how do I get uh, coffee of the same taste or the same quality across? So then the brand started coming. That is how Starbucks and others. We know if you go there, a coffee will taste like this wherever you are in the world. So that is creating a brand. So that happens by a few things. First of all, the service provider or the good supplier makes certain claims that my coffee or my produce or product will have these properties. And then once the claims are made, that is early. That is they are declaring something. But the brand gets established over time because they have to practice what they claim, and then more and more people, consumers, will consume and confirm by giving positive feedback, by what is a what you call returning customers, and then becoming a returning customer to a loyal customer. So that is how the loyalty keeps increasing. That means brand is being built, and this brand also can claim adherence to certain standards. For example, many people say the steel we use are surgical grade. So which means they are claiming certain standard compliance for the product that they give. So we are now going by brand. People say, okay, I want X brand item to be bought, be it a cell phone, be it refrigerator or a consumer appliance, be it an industrial robot. We are all talking about standards and brand. That is the current state of the art. But going forward, standards and brand alone is not acceptable or enough. People are looking at what they call traceability, because I don't want to accept just because the brand, particularly some of the cases where uh, mm, uh, okay, this is not the right platform to discuss that. Particularly the emission testing things issues that came up in spite of being a good brand. So brand alone is not enough. Even if you take the recent aircraft incident where the software was released without quality test, or some risk was taken. So brand alone is not going to help people. Brand does carry value, and it will continue to carry value. At the same time, people would like to have traceability, so that the trust is based on not just the brand, but also being able to know exactly what happened from conception to completion. So if you take to the rightmost part, a kind of a torchlight I have put. For example, if you are looking at a product, it starts from kind of from where some raw material is dug out, mined, and then where someone is processing, and then after the initial process where it is shipped to a manufacturing site, and then somebody is packaging it, and the complete thing is traced through some RFID and the tag. Ultimately, it gets distributed to the customer. So traceability is going to be the key going forward, which means Today we cannot say that I bought five materials and put together to a piece. People would like to know where those five materials came from. I know you have a process. Does your supplier also has a process? Ultimately, for example, if you take an agriculture thing, I would like to know the farmland from where this particular produce came from. Was it located close to an industrial zone? Was it located close to a forest area, or was this located to an urban area? So all these things may matter to the end consumer, and all they want to know is traceability of each and every component, each and every process, each and every person and the robot that was involved in it. We also see sometimes the food produce nowadays claim no hands-free manufacturing. So people would like to know the traceability. Okay, from which machine to which machine, how it got packaged. So okay, it uses some mechanization. Was that mechanization item also cleaned regularly? What kind of cleanliness standard that is maintained for that particular thing? So people would like to know all kind of things in terms of traceability. So this is what is going to be the next thing, and this has been accelerated today because of COVID-19. Traceability is now becoming very critical to avoid community spread, to identify potential carriers. So this is going to be extended for each and every product, every produce, every service that we are going to get. So this is what we are looking at in terms of shifting paradigm, the traceability aspect of anything and everything. So the next one is partly covered in digital transformation, but yet it requires certain different mention here, because here we are not talking about the data storage per se, but this is about the processing aspect itself. How do you manage the data, and what are the conditions under which they have to manage? So if you take any process or any industry, there is something that is happening at the soft floor, or where the action is happening. What is a ground zero, as people call it. At a ground zero level, if you really look at it, there are decisions that have to be made live. We have to take real-time decisions. For example, if somebody is cooking, what happens? If the oil starts boiling and you get too much of fume, somebody has to immediately control it. Right? It could be automated. There is no doubt, but still, the control has to happen very quickly in a certain real-time constraint, within certain milliseconds or within certain seconds. Or if we consider an automobile, when we apply brake, the vehicle must come to a full stop within certain seconds and certain distance. So these things need to be done locally. So these are called real-time requirements. So we call them, control loop. So there is a sensing. Okay, somebody applied a brake to the vehicle, and then immediately, okay, analyze what should be analyzed. Brake is applied at what force? Is it mild braking or sudden brake, and so on. And then we have to look at what speed the vehicle is going, so that they know the impact of applying brake, and then accordingly take the action how to apply brake. That action has to happen in real time. So that is called the control loop. But then at a long term, we would like to see on the average, the vehicle is running at a particular speed. Also, the way it is accelerated and decelerated by the driver and the road conditions. Based on that, we would like to optimize the mileage and tune the engine based on our parameters. We want mileage in terms of economy, or we want, pickup for racing purposes and so on. That is the optimization loop. In the optimization loop, what we are looking at is we need data over a period of time. It need not be real time. It need not be instant, which means you are looking at various days, weeks, and months. That is the timeline we are looking at. So there also we are sensing. We are sensing, at what rate vehicle is being accelerated, how much fuel is consumed, how often fuel is refilled, and so on. And then analyze all the parameters, and then take an action. What is to be tuned, or does it require cleaning of, let us say, the engine oil and so on. So those are the things to look at it. So here, what data has to be kept locally for analysis purposes, what actions and algorithms are done locally, and what can be done at a cloud level to generate value out of it. So if you look at the control loop, which is on the left hand side, then they will be at the edge. Means the data will be done locally, the processing will be local, the calculations and the computation will also be local. So sense act control happens locally. And then as we go towards optimization loop to the right, we can go to the cloud. So that is highly scalable, and we can use as many complex algorithms that are available on Earth, and then we can also crunch as much data as we would like, and we have the basically resources on our side. There is no limit to it. And then there are cases where we want something in between. We want optimization at a slightly higher level. Then we have call it fog or hybrid cloud, where the data need not go all the way to the cloud, but it can be aggregated at a plant level or city level or a block level and village level and so on. So this is another paradigm where one should be aware what algorithm and data should be pushed to the cloud and what should be kept at the edge and what should be there in between. So this clarity is another shifting paradigm, because in the beginning everybody thought, okay, let's virtualization is possible, cloud is there, let us push as much data as possible to the cloud. But that is not going to help. We need a continuum of smart sensing and computing and control locally, all the way to the optimal sensing, optimum control, and then optimum management at the cloud level, and then something in between at the fog level. So this is another shifting paradigm. So the life will continue with something on-premise, something hybrid, and something in cloud. Okay, going forward, the next key important aspect. From the till I will say 2000, early 2000 or the previous millennium, the entire world was talking about data mining, data handling, data management. There were serious reasons for it, because data storage or the memory was very expensive in 70s, 80s, 90s, even early 2000. Cost of storing data was extremely high. Cost per bit was in terms of multiple dollars in the 70s and 80s. So what happened? People took the information that was available to them. They did what they call ETL. They used to extract what is the most relevant item, or they'll make it to the most primitive format. For example, if somebody is, you know, the average is known, people will say, no, no, I'll only keep the raw data. The average can be calculated every time. So they were keeping the extracted data, or very specific subset of the entire information. And then to store also they used to transform. For example, they'll encode things. For example, instead of storing, let's say, 7 colors with GR, let's say the rainbow color, instead of writing violet, indigo, because it stores larger, they'll just put VI, just one indicator, cell encoding, and then the lookup tables say whenever I see V, it refers to violet, so that I don't have to transmit violet, which is basically 6 characters versus V as 1 character. Because not only memory was expensive, the communication was also expensive. We used to pay a lot of money even for what should I say, uh, 1 kilobit per second, 2 kilobit per second, and so on. It was very, very expensive. So that was the reality. So the ETL was very much part and parcel of the life. And then because we do ETL, there was a lot of loss of context. Because, for example, if you consider any word, only the root or the primitive data will be stored. For example, if you take text, run, running, ran, all of them will be stored as one word. So which means we lose the tense concept. The context is lost. But that was the norm till 2000. And even after that, even today, we are talking about a lot of data handling and data management. But thanks to the new technologies that are in place, like NoSQL, and then XML kind of markup languages, which are not exactly RDBMS type of data, but they are data that can handle unstructured data, so to say, and which can also handle multimedia data stores. Because of that, today we have information stores that are available, like NoSQL and all. It does give that is the current state of the art, and that gives lots and lots of benefit, because I do not have to do the extraction, transformation, and loading. Whatever data comes, we can just take that store. Definitely, this is one more reason why we are doing it, because the data generation is happening at a tremendous pace today. As more and more data gets generated, the time taken to extract and transform and load into a database is larger than the traffic that can be handled. You can think of it as a traffic situation in a toll booth where the toll collection is slower than the rate at which vehicles are accumulating. That means we have a pile up. To pay the toll, it takes hours. That is what it is. Similar thing happens with converting information to data because of ETL. The amount of data that is generated or information that is available is so humongous. ETL is becoming infeasible. So today we are storing information as is. Now that information is available as is, earlier we used to downgrade information to data, and then add process to get information back. Now that we are storing data as is, it is possible to do information manipulation to generate context out of it, which means we are really getting into systems that are knowledge systems. So today you talk to any organization, they have something called the IS, information system, or they have a team that is handling IT, which is information technology. Rarely we hear about knowledge system or knowledge technology that is in place. But even we have the CIO, who is the Chief Information Officer. Then we talk of CISO, Chief Information Security Officer. Still, we are not discussing, Chief Knowledge Officer and so on. It is not commonplace. But now that information is the baseline, not data, we can look at knowledge and contextual management as the next stage. That is where the paradigm is shifting. So instead of discussing data processing, information management, we have to target knowledge handling as the next in terms of handling things, and that is of course supported today by deep learning. We have machine learning, artificial intelligence techniques, neural networks, and so on. So quite a bit of knowledge management is coming up, and knowledge store is what is going to be the future, and that is the next paradigm or lever that is going to help us go forward. So then having uh, information and going to the knowledge or contextual level, anything contextual, I have to get a feel of what does it mean. The context has to be felt. How do you feel it? So that is where we are looking at, let's say here on the left hand side, a typical input output. I was just looking at it yesterday. What is the current figure of coronavirus cases? So I saw it. It just showed some number. Maybe at best I got recovery is shown in green, gives some positive feeling and so on. But I don't feel it. The deaths, such a huge number of casualties. There is no experience that is happening. So there are companies, that are coming with what they call, AR, VR that you already heard, augmented reality, virtual reality, and then mixed reality, and so on. They are all providing certain level of experience. Even if you go to any mall, you will find, movie theaters offering, 3D movie, 4D movie, 5D movie, where they'll say the seat in which you are having from where you are watching the movie, that will also move, vibrate in case of certain things. They call it one dimension there. Similarly, if there is a fire that is shown, hot air will be blown to the audience. So these are all providing some kind of immersive experience. So they call it 60 movies, 7D theater, and so on. We are going a little further. These are all artificial. We know that it is temporary, but how do we live it? So people are now working on immersive experience. So if I want to feel snowfall, it's I should get the snowfall at 360 degrees, not that just a cursory experience. It should be an immersive experience. That is where things are going. So again, this also indicates what kind of interdisciplinary approach that is needed, because when you say immersive experience, I would like to have an immersive experience of say sauna. Then it is not about just sauna. It is also about the safety aspect, because there will be a heat that will be associated with it. There will be humidity level that we need to be generating to create that feeling. Or I have to induce certain kind of electric pulses through the nervous system so that the body feels like that. Then how the body will react? Are we ready for it? Because if you go to a real sauna, there will be a process to follow so that the body is ready to take that experience. But when you provide an immersive experience just like that, people have theoretically have a choice to switch from one extreme to another extreme without the appropriate gap. So that is where there are checks and balances to be built. So the experience is not in isolation; it should be contextual. The moment we request for a certain experience, the system should actually tell, in your current condition, you have to do step 1, 2, 3, or this is the timeline before you can actually feel the next experience, because they are completely of different nature, and the body requires time to cycle from at a cold temperature to a hot air kind of situation, or a below sea level environmental condition to oxygen deprived 12,000 feet kind of mountain condition. So the immersive experiences technologies are actually coming up in a big way. So going forward, maybe we will not have IO devices per se. Everything will be some kind of experience that will be offered. Um, will they be called IO devices? I do not know. But what is sure is we are going to have immersive experience. That is the paradigm shift that will happen, which means the regulation will not be just the electrical and radiation. It will also be related to health. So anything and everything, it affects the health, the physical thing, the mental aspect, as well as of course the business related aspect. So the regulations will also be kind of rounded. Multiple regulatory things will come because the experience is going to be not restricted to one or two dimensions, but it is a complete immersion of the environment in which you'll be there. So after that, the last lever that I would like to point out is which is more or less well known and kind of obvious, is shifting from Capex to Opex. Of course, the most common example people cite today is the new business model that has come through with Ola, Uber, and all. They started with zero cab, zero drivers, but they run a no cab company. That is what used to happen. So that means they were completely taking care of only operational expenditure, and the capital expense was pretty much zero, except for the setting up of the business process and the workflow and the software that need to run to support this business model. So here what we are looking at is people would not like to invest money, or industry would not like to invest money based on projected savings and projected gain, which was the past for Capex. We are going to say over a period of this much. So these are the benefits over a long-term period, and then there will be some assumption on certain business growth and volume and things like that. Accordingly, capital was invested. The Opex model is different, where we are worried about based on what is needed today, we'll spend. It is instead of owning, we rent it or we lease it on a temporary basis or pay per use. Like we do not subscribe to channels. There was a time when if you look at the television, we used to get a bunch of channels. We pay a fixed amount, and that was you had no choice. Then today we are talking about pay per view. You don't have to subscribe to anything. Whatever you see, accordingly the bill will be generated. You don't watch anything, you don't pay for it. So that kind of Capex to Opex model is what is happening. It is there in aircraft industry. They kind of do wet lease, they do chartered flights, they do dry lease, various options. So as much as possible, people are going to Opex. Even I know of ABB where you can actually rent a robo, industrial robo. That is possible. There are business models that are in place. So even traditional companies, which are even industries, everyone is going from Capex to Opex. In fact, this COVID is a very good lesson why that makes sense in today's situation, because the complete economic projections have gone different. That is, kind of a shocker. The stock market is reacting in a totally different way. They do not know what to do, how to do it. So in this situation, investing in capital is a much more higher risk compared to Opex. The Opex is what is going to be the norm. That is the new normal, so to say. So that is the shifting paradigm purely from business perspective and finance perspective. And these are the 7 levers we talked about. Uh, Now that we have covered the fundamental paradigm shift that are happening. The rest will be kind of, now we are in the top tier. We can quickly cover the remaining aspects very quickly. So we hear this terminology, think global, act local. It has been told the umpteen number of times. Anybody who has done the operational research course will know that, we have to do global optimization. There is always a local minima, local maxima. There is a global minima, global maxima, and so on. That is what people talk about. But here it is something very simple. I have given a very, very down to earth example here. What is act local, think local? It is simple. I have garbage at home. So how do I clean my house? I empty it, go out. There is a outside the apartment or the street corner. There is a dumpster. I'll dump it and come back. So I have thought locally. I have acted locally. I wanted my house or my room to be clean. I have cleaned up. What happened to the mess that I have thrown out as the garbage is gone? Not my problem, because I wanted this particular house or room to be clean and I have cleaned it up. That's all. What happens, what I trash it in a corner in the dustbin, what happens, as it gets exposed to atmosphere? Is it generating some fume? Is it attracting pests? Is it attracting flies or bacteria? Is it getting, uh, getting oxidized? All those things we are not even thinking. So because, I am just thinking local about the place where I am working on. Whereas I still act locally, but I can think global. The simple example is instead of dumping it in the street corner, there is a small compost pit in which I put all my wet waste. So in 90 days, it is not a waste, it is a manure, it is a compost ready to use. I can use it for my kitchen garden or terrace garden, or I can even give it to a farmer. I can give it to the gardener of the landscaping guy nearest the park. We can donate. So there are various ways. In both cases, we cleaned up our house, uh, uh, and then certain kind of waste instead of putting in the dumpster, I just put in a compost pit, for example. So suddenly, I'm acting locally still, but we are thinking globally, because I'm ensuring that we do not create a hazard or a pollution across anywhere. So that is what the action can be same, and it has to be still done locally, because where you are, you have and the action is local. But the thinking has to be necessarily global. The same can be expanded in an industrial scenario, as you can see. If you just look at it, there is a plant which is emitting fume. The look itself is scary, because what is happening? The fumes, if not through the chimneys, going out, it will impact the plant workers and visibility. So they wanted the plant to look, visible and clean. All they did is, just like I mentioned, the garbage being put in the corner of the street. Here, it is just let out in the atmosphere at an altitude height, uh, so that, from that height, it won't settle down and impact immediately the local vicinity, but it will impact somewhere outside, maybe from 100 meters to 100 kilometers, depending on the type of fumes and so on. So this is kind of a, act local, think local. Uh, think global here could be, instead of letting the fumes out, they can put, traps to capture the solid particle. They can put filters. They can cool down the fumes so that, the temperature comes down. So they can let the clean air out, and then the waste, other things can be removed and moved across. That is quite possible. So that is what, thinking global while acting locally. So the reason this slide is important is, many times we say that, oh, I have only control of this space. How can I, impact the world? No, each and every action we do impact globally. That is something to keep in mind. If you go back to the philosophical stories, there is a Zen story. The butterfly flipped, its wings, and there is an avalanche somewhere, because everything, when the butterfly flipped its wings somewhere in the equator, there was a pressure variation, because flipping of wings changes pressure of the atmosphere at that location. So this wave impacted. Some people call it dominoes effect. That is what it is. So the flipping of a butterfly wing, which looks uh, kind of too simple to notice, can result in avalanche. In fact, you talk to any trekker or a mountaineer, they will say never ever shout while climbing in high mountain, because the sound waves can create an avalanche. So that is also, while acting locally, we have to think global. That is an extremely important aspect. So the next one is what we are talking about, digital industry. The key topic is started, uh, but since we have all the paradigms, everything in place, just one slide here. The industry can be categorized into four corners. I purposely made the arrow from the other way, so that we have to think normally in one direction. We have to think from all directions. So at the rightmost, we have traditional manual industry. We have a lot of people. The humans are doing their job. Uh, like a lot of go to any village, there will be a lot of welding and many other things that are just done by humans. They have some blower and they will do it themselves. So there, it is all human-driven industry. That is not scalable, and it is to be hazardous to the person who is doing it. But that is how industry started. When people started supporting others, that became industry. And then we got into something called assisted industries, where a lab kind of thing, where there is a machine which helps us do certain aspects. Instead of completely manual, there is a machine that is available. So a lab can do a lot of work which will take a lot of time for a human. That can be a kind of supported with a machine. That is what is the assisted industry. These two are there, already existing for ages, and everyone is familiar with it. But where we are going today is an automated industry. Automation is the name of the game today. You talk to anybody, that they are, even the business process, they are calling it RPA, robotic process automation. So they are talking about simple, processing of the supply chain or the invoicing and finance into automation. So automation is becoming the key that is currently being practiced. So these are all, for example, a CNC. CNC also uses, for example, lathe equivalent, but you can program it and stay away, and the system will run on its own. But where we want to be going is what we call autonomous. So when we say autonomous, there is a big difference between automated and autonomous. Both run on their own in one sense. So does autonomous mean automated? The answer is exactly no, because automated is a lower level of thing. Autonomous is much a higher level. Automated is a subset of autonomous. So when you say automation, what it does is it can do a certain programmed activity continuously, repeatedly without any problem. But any condition changes, it requires intervention. It requires correction and improvement. That is what the key challenge in automation is. For example, when you're driving, if you have a kind of what they call auto mode, whatever you fix the speed at which it is going. Suddenly you apply brake, immediately it goes into manual mode. Then you have to again reset it. Cruise mode cannot be reactivated. It doesn't come back on its own most of the time. So that is simple automation. So when there is a failure or when there is a change of condition, automation will fail. It cannot recover on its own. When you say autonomous, we are one step ahead. It is resilient. It is not just about being able to run on their own, but it can also do self correction. So if they find a material to be little different, it will automatically change the pressure at which certain activity is being action being applied on the item. So autonomous means it is resilient. First of all, it knows what is the defined process. Then the system will be able to understand if there is a deviation, what corrections to be made. What we call tuning in industry. Any kind of tuning is also automatically done. So it does auto tuning. And post auto tuning, in spite of that, if there is a failure, because for example, whatever auto tuning we do, if there is a power cut, for example, power outage, what happens? The system has to restart. So the system will know, okay, where I stopped, then it knows what to clean up, and it will gracefully restart in such a way that it will run on its own. So autonomous means pretty much there is no human intervention for the plant to run. Automation means the plant will run on its own till it is disturbed or it stops because of some factor. It could be because of the raw material not being the same, or it is because the automation duration is over. It was supposed to produce 100 pieces, it produced and it stopped. It doesn't start the next shift, for example, or it doesn't sense the next load that comes automatically to restart, or it is not connected to, for example, the supply chain to say that the stock is now cleared from the inventory that needs to be refilled. I have to reproduce. So those kind of decision. Autonomous means it is resilient. It can do everything on its own. That is what is the holy grail the industry is looking at. We are targeting. It is somewhat like those who are well versed with mathematics know that there is something called the limit tending to something. That means it is asymptotic. Uh, we will. It is not expected that we will ever reach that stage, but we will reach as close as possible. So automation to autonomous is an asymptotic journey, and many people are at different stages. But in the end, there will be a human always required. Only thing, the dependency of the human will keep coming down. That is what the digital industry, the autonomous mode is looking at. So what are the levers to achieve this digital industry, keeping the shifting paradigms in mind, and thinking globally while acting locally? There are many technologies. So for the sake of time, to avoid uh, being repetitive, I have mentioned some 7 levers. One aspect is the smart sensor. I have one slide on it so that just to cover one of them. Then connectivity. We are talking about 5G. We are talking about many kind of industrial IoT connectivities and all. And then cloud technologies, data lake, where any kind of data or information can be dumped. There is no ETL. It is elastic. There is no capacity limit, and it can handle any kind of data, multimedia, real-time process data, business data, personal data, images, videos, live streaming, any kind of data. And then the immersive experiences enabled by AR, VR, and related technologies, the analytics because of artificial intelligence and machine learning, and of course, what we never talked all the way is the smart material. Um, the material which themselves are becoming much more smarter. They can adapt to the environment, and that is what is enabling the smart sensors. There is interconnect between them, but smart materials are something that are very important. So that indicates again how interdisciplinary we are talking about. We are talking about fabrics. We are talking about materials which are not traditionally engineering or typical business. So these are all the levers, the 7 levers. We talked about 7 paradigms, and here we are talking about the 7 levers, which enable this digital industry to go forward. So just in the interest of time, I'll just cover what happened with sensor. So out of the 7 levers, if we look at sensor, there was a time, we had a purely mechanical transducer way back in 1800. You can actually link each of them to the industrial revolution. Industry 1.0 revolution happened when we had mechanical transducer. Then the electrical sensor came, in 1900 when the industrial revolution 2 happened. And then going further, sensor moved further with electronically IEDs, as we call it, intelligent electronic devices. They are part of industry 3.0. But going forward, we are looking at smart sensors. Some of them are available, many are in process. So that is what we are looking at it. So sensors are evolved. Like that, each and every lever that we mentioned in the previous slide, they are all going through this kind of evolutionary cycle to enable the digital industry. Okay. So with this, what kind of opportunities we have? The opportunities typically people look at either R&D, or people are looking at or if they're extrovert, they would like to be connected to consumer. They want customer support, marketing, sales, and all. Uh, just to give a right viewpoint, so that what kind of competition or opportunities we are looking at it. If you look at the research and development, uh, for every research and development which requires a scientific temperament, requires perseverance, and ready to accept a lot of failures and experimentation, we need few people there. If there are X number of people in our research, their ideas need to be designed and developed into usable items. what we call prototype and validating the designs or ideas. That is done by design and development teams or R&D teams. So if there are X number of researchers, we typically have 10x kind of design development labs, because one idea is checked by many people how I can implement for the condition in which we look at it. And then once for each and every design and development, again there is a 10x kind of engineering and production. For example, you design one vehicle and there are variants we need to come out, so that we give customers various choices based on, we look at premier market to mid segment market to entry level market and so on. So we are looking at engineering and production, which is another 10x. So if it is X, then 10x, then production can be 100x or 1000x in that range. And then the exponential growth happens with marketing and sales, because production can be in millions and in number. So to sell them and to market them, we need much more larger workforce. So a production, each factory requires a number of marketing officers. As you can see, every industry, if they have a factory, they will have globally anywhere between 20 to 2,000 marketing officers for one factory. That is the kind of explosion. And then for everything that is sold, there is a lifetime of the item that is sold. The service and support continues to stay. For example, if you have one car dealer, how many mechanic shops are there? That is the service and support. So if you really look at it, the opportunities are exponentially increasing as you move from left to right. For every X number of people that who are actually doing research, we need probably a million service and support people if it is successful across the value chain. So that is what the kind of opportunities that we are looking at. So if you are looking at a carrier, or if you want to shift area, we should know what kind of numbers we are looking at, what is the market space that is available to enter. The size of the market is very, very important. And this just gives a glimpse of that. And then, yeah, before we throw it to open, this is something I would like to spend a couple of minutes on. This will be my final thought. So in the end, uh, for anything to be successful, there are certain necessary conditions and there are certain sufficient conditions. So, say for example, what is a necessary condition? What is a sufficient condition? Um, a necessary condition is, for example, hydrogen and oxygen is needed to get water. These molecules are enough. But just these two are they enough? These are necessary but not sufficient. We need to produce a condition in which that the oxygen atom actually bonds with hydrogen atom, two of them, to create water molecule. And then the temperature also has to be such that it doesn't get evaporated. It should be in a form that can be used by us. So that is what happened. So the necessary and sufficient conditions is what I look at it. So what is necessary is first to be human. That is basic requirement. Let us not look at just the numbers, become too objective. After all, if something that distinguishes us from robots and others, it is what we call the sixth sense, or the ability to think on our own and handle situations that are not already encountered. We are able to handle situation on our own. So that intuition and the intelligence of the human being, that be human nature, is one necessary condition. If you do that, obviously we'll automatically look into acting locally but keeping global in mind. But how do we reach the sufficiency condition? As a human, the first thing we need to develop is be empathetic. So how the other person is going to feel. This part is extremely important, because unless I know how the other collaborator is feeling, we cannot collaborate, because otherwise there will be no common goal. We need to collaborate with people to create interdisciplinary digital industry. We mentioned that one of the shifting paradigm is being interdisciplinary. That means we should be able to talk to people with various backgrounds and experience and different industries, different streams through which they come through. And people always talk about right brain versus left brain. But in this case, they have to collaborate to do something. So collaboration happens when you are empathetical. That means we give an sincere ear to the other party and feel for them, and they feel for us. Then there is a common synergy, there is a common goal that can happen. When that happens, then what we can do is we can offer personalized experience, because any service we give has to be personalized. That is why the immersive experience paradigm is very important, because today we are virtually isolated and working from home. So any experience has to be personal, because I am not in a community. I am at my place, just staring at this webcam, not seeing any of you. Same thing with you. You are at your own place. So everybody would like to have the personalized experience. That is what is the requirement. Nobody wants to, be just a number or just a subject. Everybody wants a personalized treatment. Be treated as an individual. Be treated as a human. So every service, every solution has to be offering a personalized experience, and at the same time not compromising the privacy and security requirements. That is an extremely important aspect here again, because GDPR norms are there in place, and the DSA is again promoting that in a big way. Why it is important. So everybody today wants a personalized experience without compromising on the security and privacy. So that is what will keep the business running. Today, if you want to have life going smoothly, how do you make a live for a tomorrow? Only by offering a personalized experience, keeping in mind security and privacy. So that is possible only if we collaborate with others. And to collaborate, we have to be empathetical. To develop the concept of empathy, we should be a human at first. So, from being a necessary human being to offer the current requirement of personalized experience or service in a secure and privacy protected way, we need to be able to empathize and collaborate and deliver things. And these all will happen um, if and only if we understand where the world is going, and how much open we are, and understand the shifting paradise levers. The rest are all enablers, but this is what, as an individual, what we do. This is what is uh, will make a difference between a machine and a human, between a successful life versus just a dashboard success versus a success that is internal to the person, intrinsic success versus extrinsic success, so to say. So one can be externally successful, but without this being human and offer personalized service to everyone, I don't think intrinsically one can be claiming successful. So with that, I'll make a pause, and I think I'm okay to take the question. Thank you again, DSA, and all the attendees for being part of this session. And I do believe some chats that I can see blinking. So open for interaction.
Thank you so much, Sudarshan, for taking up today's session with us on the interesting topic of levels of digital industry. We do have some questions. There is one on how to handle knowledge store system.
Okay.
So, T.R. Rangaswamy.
So thank you for the question, sir, Mr. Rangaswamy. Definitely, knowledge store is something very important. So how do we handle knowledge store? So knowledge store is, as I mentioned, today we are able to store information in a data lake, or in a huge data repository, and that is just a collection as it is. Correct. This needs to be processed. So when we say prescriptive analytics, for example, based on the past data, certain decisions or actions are recommended. So these are all knowledge bits. So this knowledge for situation specific, contextual specific decisions or solutions or experiences, they also need to be made part of the store. Basically, what we are trying to do is uh, information along with the processed data and the metadata. Together, we create one more level of what should say output. So that is generated, that is kept as a knowledge store. So this is something we have to define. This is my way of thinking. There could be alternate ways, and this may not be the one and only way or unique way. But the knowledge store is where I do not want to estimate a potential situation. I'll give a very probably a very simple example. For example, there is when you're talking about, again, COVID-19 is the current thing. We are looking at any drug that is made. We look at what they call drug protein interaction is what is required to check for any allergic reaction and so on. So what means our human body uh, has certain kinds of proteins that it can handle. And then the drugs are also certain types of drugs. Each drug with a given type of protein, how it interacts. Based on that, they decide whether it is safe for use or not safe for use. That is how it is done. So in the past, I know this was done through certain simulation because people know the property of the protein, that is molecule. People also know the properties of the drug, which is a chemical element. So between the two, they create what are the ways they can interact, under what conditions, and what are the outcomes. Does the protein or the cell affect the drug, or drug affects the protein, and so on? Because they are used for treatment of certain conditions. So it was always simulated. And for every single drug, single protein interaction, simulation used to happen. And then people rarely have require one drug and one clearance. We always have a multivitamin tablet, and we are in multiple health conditions. So the treatment is not with one drug. We normally end up getting multiple drugs, which means we are looking at a multi-protein, multi-drug interaction. And simulation of that is extremely time-consuming and complex. So what people are doing is now they are setting up supercomputers. So instead of experimenting with every drug protein and doing an analysis, typically if you have a normal standard single core computer desktop, a single protein, single drug interaction, uh, a good simulation will take about 15 to 20 minutes from what I know. So now think about, hundreds of proteins and thousands of drugs. Then in combination, the permutation combination, how long does it take to generate the permutation combination? So now what people are doing is they are having a supercomputing facility. In that facility, they are doing the simulation on a continuous basis proactively. So what it means is, in the end, the simulations are all the permutation combination simulations are done, which means I do have a list of lookup table. You tell me a protein, name a drug, and name another drug. I know for this set of proteins and this set of drugs, these are the possible outcomes already done. So that lookup table is my knowledge store. That means I have done a lot of simulation and analysis that is already done and do it. Same thing we do in terms of industry or digital twin. So we can predict the life cycle, the time to fail. So how do we reduce the unplanned downtime? By creating a digital twin of a particular equipment, a motor or a robo. And then, while the real machine is running in a particular speed, robo is used for a particular thing. The digital thing can be made to run much faster and longer, and then to see where it is failing and why it is failing. So we can be prepared for it and reduce the unplanned downtime. This is the kind of knowledge store that we need to create. And another example could be what we used to do in the past, the pressure cooker testing and the accelerator testing. Now this can be done in a digital way. That is what digital industry is talking about. The ability to predict the future things and keep potential actions and results in place based on the available information proactively. That is what I will call it a knowledge. I hope I answered your question.
Sure, Sudarshan. Thank you so much. I think there is somebody who said that the last part of your session where you mentioned we need to be human and not become a robot by involving ourselves. People are really appreciating that part. And there's another question from Mr. Mohan. He says he wants to hear some views on ethical considerations in digital industries as predictive and prescriptive decision that it may impact.
Yeah, thank you, Dr. Mohan. This is an extremely important question, the ethics. Um, uh, Very important because we do hear stories of, the machines. We have seen movies, for example, that the Yandran 2, whatever it is. The machine does not understand the concept of a society, the concept of, let us say, modesty and so on. So it just goes by what is it is programmed for. So the ethical part is extremely important. And how can we do it? For that, again, this is where the knowledge store comes into picture. So every society defines what is ethical, what is legal, what is moral. So the compass of these three have to be together. Today, most of the time, the systems are defined keeping the legal aspects in mind, and then there are some local adaptations if there is a human interaction, just to get along with the culture, so to say. But just like we earlier spoke about, people talked about intelligent quotient. Now people are talking about two more quotient: spiritual quotient and as well as environmental quotient. So today we are talking about the triad. Intelligent to IQ alone is not enough. An IQ can make someone a great guy, but that fellow with no spirituality, no emotional intelligence, and so on, quotient. And those people are unlikely to succeed because they do not have the empathy, they cannot collaborate. They'll be people who look at them, oh, that fellow is, uh, so to say, pure task oriented. These are all part of, again, Johari Vidya that they do. But here, coming back to this, going forward in the digital industry, I think, like I mentioned, when you say immersive experience, there are various ways one can also be made addict of certain things. So that is where the ethical and other things come into consideration. That is why I mentioned about regulation that will not be related to one industry. We will have regulations that are related to healthcare, that are related to environment. They will all evolve, in my view. So the ethical, moral, as well as legal, all the three obligations will be made part and parcel of the digital industry, and that is where it will mature. Till the time there will be a lot of glitches one can expect. That will be a lessons learned, and we will have to pay some price for it for sure. But when we mature to digital industry, these three will become a triad, and nobody can claim one without the other. That is what I feel, Dr.
Thank you so much, Sudarshan. I think those were the few questions that we had. Most of the people, they said they faced some audio issues in between. So to all those
Okay.
people, we will be sharing the recording of this session. And if you have any questions, you can always email it to us at ncoe@dsci.in, and we can pass on those questions to Mr. Sudarshan. Or Mr. Sudarshan, if you want to share your email ID, then people can directly send you their questions.
Yeah, so my email ID was there in the very first slide. Maybe I'll go to the first slide. So thank you.
Sure.
I'll go to the first slide. So yeah, it's available here. So I have given both no IEEE email ID as well as the Gmail ID.
Perfect.
Feel free to write to me. Thank you so much for your time and patience, and appreciate your support.
Thank you so much, Sudarshan. It was a pleasure to have you with us here today. And thank you everyone who joined today's session. And we'll be seeing you in our future sessions of National COE. Thank you, everyone. Have a nice day.